that I teach in AP Cal for the first time their senior year that did not come through my class make that mistake all the time. And believe me, AP Cal will say, what's the maximum value? And people write down a point. And a point will be an option on a multiple choice question, but so will the Y value. So be really careful when I ask you on this test what the max of the min is, that don't give me the vertex, give me the Y coordinate of that vertex. All right. So if you're looking at an equation like this, if it's in this form, the H and the K represent the X coordinate and the Y coordinate of your vertex. All right. Now you'll notice that in the formula, it's X minus the H. All right. So when I look right here and I see X minus 2, what would the H be? 2, because you're subtracting, what you're subtracting. If I see X plus 3, what would the H value be? Negative 3, because you're technically subtracting a negative 3, and that's why it's plus. So, and the same thing with the Y. If that's a Y minus 1, then the K value is 1. If that's a Y plus 4, the K value is negative 4. So from that number that you're subtracting from X, and from the number you're subtracting from Y, that's your vertex. But you can only find that if it's in this form. Now, there's actually, you can find it if it's in the other form. I'll show you a trick to that, but not right this second. So right here, I know that the vertex is at 2, 1. I can go to my graph, go over 2, up 1, and I can mark that point. That's going to be the vertex of this graph. Pretty easy to find. Same thing here. I know the vertex is at negative 3, negative 4. I can go left 3, down 4, mark that point. That will be the vertex of this graph. Okay, now, the direction that the graph goes, whether it goes up or down, that's going to be what we call determined by the positive or the negative A value. The A value, if you look back at is the number that you have on the outside of that factored expression. It's to the left of the X minus H squared. So if I have it in this form and I look there and I see my A value is negative, because my A value is negative, I know the graph is going to be going down. If the A value is positive, I know the graph is going to be moving up. Now, the actual quantity, the A value, is going to determine, if it's positive, I know it's going up, but the size of that A value determines whether it's going up and it's really thin, whether it's going up and it's really wide. People call that sometimes stretched or shrunk, because what they're saying is that A value is affecting what the Y value is doing. What they call maybe a normal Y value might go a certain amount, but if the A is bigger, it will stretch that Y value and make it steeper or thinner kind of looking. Or if it's a fraction, like maybe 1/10, it might shrink those Y values down, which gives it the impression that it's a little opened a little bit wider. Okay, so the size of that, I'll talk about how to use that number to determine whether, or the actual width of it. But for right now, if you see a value that's smaller than 0, you know it's going down. If it's bigger than 0, it's going up. Also, if you see a number that's in between negative 1 and 1, okay, numbers that are between negative 1 and 1, like 1/10, 1/12, 3/20, small fractions that are close to 0, kind of on a number line close to 0, they give you kind of wider looking parabolas. They tend to be opened up. They're a little bit more open. Okay, values that are not between negative 1 and 1, values like 2 or 4 or negative 10 that are further away from 0, they make the graph skinnier or skinnier, whether it's going up or down. Are y'all with me so far? Okay, so right now I technically would not have enough to sketch these unless I plotted points, but I can always plot points, right? So, but I do have enough to get the vertex, to know that this thing is going down, get the vertex, know that it's going up, and then what I want to talk about now is how can you actually use this information to sketch these graphs and do other stuff. But right here, if I ask you for the max, what are you going to tell me? 1. If I ask you right here, what's the min, what are you going to tell me? Negative 4. Now, one other question. What if I ask you for the min here? There is none. Now, it's tempting to say negative infinity. But remember, min means what? The minimum Y value. And a value is a number that you can touch and feel and hold and see. And infinity is an idea that something is unbounded in a very large or very small direction. And because it's not a value, I can't say infinity or negative infinity. I would just say no min, no max. Are y'all with me? Or you could say the min does not exist here and the max does not exist there. Now, by the way, I'll also mention this. There is something called a relative min and a relative max. We're not going to really get into that here, but a relative min may not be the smallest y value, but it's the smallest y value in the area. So like, what if I had a cubic graph? You know, a cubic graph kind of goes like this. You know, remember the x cubed look like that, but a lot of times they have a little wiggle to them. If I had a cubic graph, it's going up forever, right? So there's no max. And it's also going down forever, so there's no min. But there was a place that had a little peak, right? So that little y value there would be the relative max, because it's the max in that area. And this right here would be a relative min, but there wouldn't be an overall, like a global max or a global min. That won't matter here, because these aren't cubics. But they will matter later on when we get into calculus and other things. Okay? So anyway, let's talk about these. From these 5 equations right here, I just want, can you tell me what the vertex is? Can you tell me which way it's opening? Can you tell me, is it wider or skinnier? And can you give me the max or the min? So real quickly, just to make sure you're okay, I have put these graphs either into parabolic form or something really close. So let's see if you can tell me. What would be the vertex of this? First one. Talk to me. -4, 2. Don't accidentally say 2, -4, right? Where the x coordinates with the x, y coordinates with y. So -4, 2. And which direction would this be opening? Opening down. Would this be wider or skinnier than normal? And by the way, normal would be like if A was 1. It would be a little skinnier because it's bigger or smaller than 1 or -1, right? And then what would the max or the min be? And what would it be? Which one would it have and what would it be? If it's going down, it what? It has a max, and the max would be 2, because it's the y coordinate of the vertex. Right? And the min would just not exist. Right here, what's the vertex? 4, -1. Which way is it open? Down again. Is it wider or skinnier than normal? A little bit wider, because it's between 1 and -1. One of those fractions or decimals between 1 and -1. And would this have a max or a min? A max, and what would the max be? -1, okay? Right here, what would the vertex be? On number 3. -4, 0, right? Because that's kind of like a y minus 0. So -4, 0, which direction would it be going? Open? Be opening up because it's positive. Would it be skinnier or wider? A little bit skinnier, right? And then what would it have, a max or a min? Have a min because it's going up, so it has a min, and what would that min be? At 0. Good. And right here, from that right there, can you tell the max or a min? Now that's not in the right form. What would I have to do to get that in the right form? You see it? I'd have to subtract the 5, right? Because this is not x plus 5 squared. Don't confuse it with that. Are you seeing the difference? That is not it right there. What you have is this 5 could easily be subtracted to the other side. Sorry. And that would give me y minus 7, -3x squared. So what's my vertex here? 0, 7. Do y'all see that? You see how I can mess with you? An inexperienced student on their test, it's really easy to go, oh yeah, the vertex is -5, 2. Can you see how you could get sucked in there? But remember, that would not be right, because that would only be true if that was being subtracted, or actually added to the x inside of the squared part. But you can see those values are not inside right there. So you would have to not do that, and certainly don't make that mistake. So right here, I have a y minus a 7, and you would have to say the vertex was 0, +7. And which direction is this one going? Down, skinnier or wider? A little bit skinnier, and would it have a max or a min? It would have a max, and the max would be +7. Good. And then over here, this is kind of the form you see a lot of times with current books. They don't put y plus 4. They move the 4 over. So what would be your vertex here? To -4, right? Because if I move that -4 by adding 4 to both sides, you would have had a y plus 4 there, which would have given you a -4. So be careful about something like that. If it's not quite in the form that we discussed, manipulate it a little bit and get it in that right form. And then which way is this thing going? Down, and is it a little wider or a little skinnier? Skinnier. I'm glad you saw that. A lot of people get in their head it's just a fraction that makes it skinny, right? But it's, remember, it's a number between -1 and 1 where the graph becomes a little skinnier, and this is actually 1.5, but -1.5. So it's starting to get a little bit skinnier than normal, but not a lot. You probably wouldn't even notice. But and then the max would be what? -4, because that's the y-coordinate of the vertex. All right, so let's talk about intercepts. Do y'all remember what an intercept is? So if I say the word intercept, I mean what? Crosses either the x or the y. Now, if I want an x-intercept, what do? Plug in 0 for y, which makes sense, right? Because every point on the x-axis has a y-coordinate of 0. So if I ask you for an x-intercept, just come in here, plug in a 0 for a y. Now, look at the math on this real quickly. If I plug the 0 in for y, I'm going to get, so I'm going to say when y is 0, if I do that, I get this. What will you do to solve for x here? You got a couple options. I say isolate the x. Just start undoing all the junk that's happened to that x. But the last thing I'm going to do is FOIL that out. If I FOIL that thing out and write x squared plus 8x plus 16 and distribute the -3 in and add the 2 over there, I will get a quadratic equation, right? I'll get that. But then what will I have to do to find x? I'll have to resolve it using either factoring, if you got lucky enough to factor, which is not going to work here, or you maybe have to pull out completing the square or the quadratic formula. To me, the square has already been completed, hasn't it? So really, all you have to do is divide by that -3, and then square root both sides. Now, when I do square root both sides, I do get rid of that squared, and that gives me x plus 4. But what happens here on the left? I get plus or minus, and can I have a 3 in the bottom of a radical? So I would have to rationalize that denominator, which is going to give me a √6 over a 3. And then the last step would be to do what? Add 4. Now, what in the world does this mean to you for x-intercepts? It means you have what? 2 x-intercepts that are located there. Well, what does that mean? If I told you to plot that. So you'd have to start at 4, right, which is 1, 2, 3, 4, and you'd have to add whatever. Oh, sorry. You'd have to start at -4. Sorry about that. And then you'd have to what? Add √6 over 3 and subtract √6 over 3. So if you are just eyeballing this thing and trying to sketch it, what's √6? Just ballpark me. Like 2-ish, right? Because if √4 is 2 and √9 is 3, √6 is pretty close dead in the middle, right? I mean, it's not perfectly in the middle, but it's about 2.5. So from -4, I would be adding about 2.5, and I would be right there, and I would be subtracting. Oh, dang it. So 2.5 over 3 would give me about what? So about 0.8-ish. Sorry. So at -4, I would be adding about a 0.8, and I would be subtracting about a 0.8 from that. I gained it. Are y'all kind of seeing that from there? I mean, you could go through and go -4 plus √6 over 3, -4 minus. But if you were asked to plot these, you could go, all right, from there, I'm going to add a little bit, subtract a little bit, and those would be my 2 values. And you can see that at -4 up to, there's my vertex. That kind of makes sense, right? Because I would be on either side of that, heading down, right? And you could kind of get a quick sketch using those intercepts. Now, what would I do to find the y-intercepts? Well, are there y-intercepts? Yeah, if a parabola is going like this or going like this, it's only going to head through that y-axis one time, right? Now, it's possible not to have x-intercepts. Like if my vertex is right here and I'm going up, I'm not going to have x-intercepts. If my vertex is right there and I'm going down, I'm not going to have x-intercepts. I can still plug 0 in for y, but what do you think happens in the process of me solving?
You get something for 0.
No, you get an imaginary number. What will happen, you'll see that I think on maybe one of these, but you would actually end up with an imaginary number. If you get an imaginary number, we're still going to call those roots or solutions, but they're imaginary solutions. Okay, but we're not going to call them x-intercepts if they don't cross the x-axis. But parabolas that go up or down will always have one y-intercept. And you can see, how do you find a y-intercept, do you think? You plug in 0 for x. That's going to be really easy to do. Check it out. You're just going to plug. You're going to say, all right, y-intercept occurs when x is 0. And when I do that, you plug that in there and you get 0 plus 4 squared, right? And all you got to do is multiply and add that 2. And you can see that right here. When you plotted that point, when you plotted those intercepts, it was going down and we were way away from that y-axis. We're going to have to go way down before we ever hit that y-axis. Sure enough, it was down there at -46. What about here finding an x-intercept? If I want to find x-intercepts, I plug in 0 for y. That gives me this. And what are you going to have to do to find those? What if it doesn't factor? I don't. Actually, this one probably does factor. You pull out the quadratic formula right now. You would have gotten lucky on this one. It actually did factor. So I get x equals 1/2, x equals 1. But if it didn't factor, you pull out the quadratic formula. Just means you're going to get an uglier answer, kind of like you did on number 1. And if I want to find the y-intercepts, this is super easy, right? Plugging in x equals 0 is what? Y is 1. And it probably is better to write your intercepts as points because they actually are points. I don't think I take off. So on this uglier, like right here, it would probably be better to write this as 0, -46. It would probably be better to write these as 1/2 0 and 1 0 and y-intercepts as 0, 1. That's better. Okay, and a lot of times your answers would be as points. But if I say what's the intercept, I'm not going to count off. I think I used to, but I don't think I count off anymore if you just write out the actual values.
Can we call our y-intercept b? Is that just for?
I would call it the y-intercept in a situation like that. But it is in that particular form, it's b. But in this form, it's not, right? That's b, -3. So I probably wouldn't do that here. I would just label it as a y-intercept. And then finally over here, what do you notice about this? Your x-intercept. All right, so x-intercept, y is 0. If I do that, look what happens. I divide by a -2. And then right here, when I square root it, what do you see? I would have an imaginary number. So if my question for you is, what are the x-intercepts? What do you say? Don't write down imaginary answers, because imaginary answers aren't intercepts, are they? This thing does not have x-intercepts. I mean, look at it. If you go to 3, -1, and mark that point right there, and you know it's going down, you're not going to have x-intercepts. You do not want to write your answer down there. So you would say there are no x-intercepts. Now, if I turn it around and say, what are the imaginary solutions to this graph? Or what are the imaginary roots? If I do that, then finish it up, right? You got plus or minus. You can pull your I out. You're going to have to rationalize. Remember how to rationalize root 2 over 2? I mean, multiply by root 2 and root 2 on the top and the bottom. And then add that 3 to the other side. So those would be your imaginary solutions, although it probably look better writing that I at the end or on the top in front of the root 2. And those would be your imaginary answers. But again, if the question is, what are the intercepts? We don't call these intercepts. These would be called imaginary solutions or imaginary roots to the graph. But you are going to have a y-intercept. So how do you find the y-intercept? X is 0, and you can do almost that in your head. Y plus 1 is -2. I plug a 0 in there. -3 squared is 9. Take that -18, subtract the 1 from it. So your y-intercept occurred down there at -19. You tracking?
So we just write no if they're wrong.
If the question is find the intercepts, that would be the only intercept. You go to a Vestavia tournament and you'll see a question right here and it will say, what are the sum of the intercepts? If I come in here and I go, oh, well, I've got to add that to that, and then also to that, I'm going to get a different answer, aren't I? Because even though that might cancel, I'm going to get 6 and that's -13. But I'm going to miss this question because those aren't intercepts, are they? My answer should be for the sum of the solutions, or the sum of the intercepts, -19. Now, if you were to get a question like this and it said, what are the sum of the or what are the roots or whatever, then that might be different. But again, imaginary roots and imaginary solutions are not x-intercepts because they don't cross the x-axis. All right, moving on. Axis of symmetry. You probably know what the axis of symmetry is. The axis of symmetry for a graph, the axis of symmetry for a graph like this, you can see this. The vertex is going to be at -4, 2, right? So left 4, up 2. There's your vertex. And you know that this graph is going to be going down, right? And it's going to be a little skinnier. We'll talk about exactly how to do that later. So maybe the graph looks something like this, okay? The axis of symmetry is that line, right, that splits that graph into symmetric halves. Are you seeing this? So what is the equation of the line here that split this right through there? What is the equation of that line? It's x equal what? -4. Well, you can draw a picture of this if you want, but the easiest way to find the axis of symmetry on a parabola, if it's in parabolic form, is to just grab whatever's being squared here and set it equal to 0 and solve. And you don't even have to think about the picture or anything. All right? And the nice thing about that is even when you have parabolas going sideways, where that becomes an x and that becomes a y, this is still a part that you can set equal to 0 and get the equation of your axis of symmetry. So what's the equation of your axis of symmetry here? X equal 2. What's the equation of your axis of symmetry here? X equal -7. So really easy to find those. And again, if I start making parabolas go left and right, you can always take this part, set it equal to 0 and solve. You can do that with work or in your head. That's always going to give you the equation of that axis of symmetry, which really is not doing a whole lot for you, except that you know that if I have something to the right 1 and down 4, then I have something to the left 1 and down 4. It's just you know that you're going to have symmetric values on each side because of that axis and because of the behavior of these parameters. So far, so good? Yeah? All right. Graphing them. So, obviously, when you graph functions, if ever in doubt, which I do not encourage you to do this, you could always make a little chart, right? You could make a little x, y, like this, and just start plugging in x values, any ones you want, plug them into the equation, solve for y, take those, and you have points, and you can come down here and mark those points on the graph. I don't need you to do that. When you're sketching parabolas, I really just want 3 points. Now, if the 3 points you get are really close together, like if you had 3 points like this, and you have this big graph I'm trying to get you to graph on, and you're like, okay, I know it goes through those, it's going to be hard to really draw an accurate graph with just those 3. But I'm going to show you 2 strategies, depending on the situation, where that doesn't happen much. Where either this happens, where you get 3 points that are nice and spread out, and it makes it pretty easy to come in here and sketch, or maybe you get 3 points that are kind of like this, and it makes it easy to stretch. So the strategies I'm going to give you, there's two different ones. They will help you when your A value is bigger, like bigger than 1, and they will help you when your A value is a smaller fraction when it's closer to 0. And here are these two strategies. Okay, so for the first one, and by the way, the strategies work for both. Like no matter what situation I have, either of these strategies will work, but they won't always give you 3 points that are nice for you. So here's the first one. I've got to talk a little bit more about parabolas than I really want to. But since we're going to cover parabolas in the next chapter anyway, we're going to go about it this way. So what you don't know yet, perhaps, is the nature of a parabola. A parabola is built on a couple of different definitions. One of them has to do with a cone, a slice through a cone. I have a cone right here, and I'm missing a piece, but you can see right here on this cone, if I take this thing and I make a slice in a cone, right, and the slice is parallel to the edge of the side. If I do that, that slice creates a parabola. And that's why it is one of the conic sections, because I'm sectioning off a cone. Okay? Other slices make different things. If I make a slice that goes perpendicular to the axis, it gives me a circle. If I make a slice that is tilted a little bit, goes in one outside the other, but not perpendicular, it gives me an ellipse. There are different slices that give me different things. We'll talk about all those next chapter. Right? Another definition is an algebraic definition, and it has to do with distances from a point and a line. Now stay with me. So one of the definitions of a parabola is all of the points that are the same distance from a point called a focus as they are from a line called a directrix. Now, I didn't even put the directrix in here because we're not going to really have to need it right here. But here will be my directrix. Okay? And again, not a big deal right here. I'm just going to call that DIR, but it's spelled directrix. Now, this line and this point called the focus are what guide my parabola. So if I were to draw, and I'll do it in pink, all the points that are the same distance from this focus as they are from this directrix, the most obvious one's the vertex, right? It's 2 away from here and 2 away from here. A couple of other points are this point there and this point here, because you can see this point right here is 4 away from the focus, but it's also 4 away from the directrix. Now, these 2 points are the endpoints of something called the lattice rectum. I normally have people chuckle when I say lattice rectum, but if you look at it, rectum means opening, okay? Lattice comes from something in Latin having to do with width, but essentially means the width of the opening. See, I'm getting chuckles. Okay, so the bottom line is the lattice rectum right here, that length, if I could somehow find it, it could really help me get 2 points. Well, here's the beautiful thing about the length of the lattice rectum. It is always equal to the reciprocal of your A. So if you look at a parabola, like this one down here, and you go, oh, there's my A value, 1/16. If you flip it, you get what? 16 is the length of my lattice rectum. If I look down here and I see -1/8, you got to make it positive too because it's a length. So it's like absolute value of the reciprocal. If I look at that A and I see -1/8, what happens when you flip it and make it positive? I get 8. That is the length of my lattice rectum. If I look right here and I see 1/10, flip it, I get 10. That is the length of my lattice rectum. Now the question now is, where do I make that length? Well, it just so happens that the distance from the focus to the vertex is something that we call C. C is always 1/4 of your lattice rectum. So if I can find the lattice rectum, which in this case would have been 8, right? So I guess my A value would have been 1/8. If I can find the lattice rectum and take 1/4 of it, I get my C value. So now I know C is 2. So all I have to do to get those 2 points is to right there at the vertex, go up 2, over a total of 8 for each way, and I've got 2 extra points, and I can sketch my graph. And with that, I don't even need to know about the directions, because I'm kind of skipping by. So with that in mind, let's look at these. right here, real quickly, just run through this. What is the length of the lattice rectum here? 16, because I flipped the A. What is the length of the lattice rectum there? 8. Remember, it's a length, so I always take the absolute value of it, make it positive. So positive 8. And what's the length of my lattice rectum here? 10. So how would I find the C value, which is your distance from your vertex to that focus? And the lattice rectum always goes through that focus. You saw that in the picture above right there, right? So how do I find the C value? I take 1/4 of that 16 and get 4. I take 1/4 of that 8 and get 2, right? And I take 1/4 of that 10 and I get 2.5. Now, if that's the case, and I already look up here and see that my vertex is -1, 2, which I didn't technically ask you here, and I see my vertex is 2, -5, and I see my vertex is -7, 0, and I recognize that my A value is positive, so my graph is going up on this one. My A value is negative, so my graph is going down. My A value is positive, so my graph is going up. If I know my vertex is at -1, 2, and I'm going up, how much would I go up to get to the focus? How much? 4. So if I wanted to know the focus, actually, there's where I asked the vertex. If I want to know the focus, I'm just going to go up 4, up C, from there, which gives me what point? -1 what? 6? So right there, that's the vertex. Here, let me just rewrite it a little bit smaller. The focus would be -1, 6. Right here, my vertex is 2, -5. What do I do to get to the focus on this one since the graph is going down? I do what? To get to the focus. Okay. Down 2, so subtract 2. That will give me 2, -7. And right here, if my vertex is -7, 0, and I'm going up, how much am I going up? Up 2.5, so I'm going to add 2.5. And at this point, guys, look how you're home free. So here's my vertex. At -1, 2, I mark my vertex. I'm going to mark go up 4. 1, 2, 3, 4. That gives me -1, 6. There's my focus. And the lattice rectum is the width of the parabola at the focus. And what is my width? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 to the right. I'm going to go 8 to the left. And look, there are my other 2 points. So I'm just going to sketch my parabola as good as I can through those extra 2 points. Are you with me? Okay, remember 2, -5 and 2, -7. So right here, we said the vertex was 2, -5. We said the focus was 2, -7, right? And we said the C value was 2, and the lattice rectum was 8. So if that's my vertex, and I go down 2 for my focus, what do I do with the lattice rectum? From the focus, I do what? Go over a total of a width of 8. So I'm going to go 4 to the right, 1, 2, 3, 4 to the left, and I'm going to sketch my graph through there. So technically, I don't know why I put focus thing. There's my focus right there. And then the last one, I can't even see. But here I had what? -7, 0. So right here, -7, 0 was my okay. So at -7, 0, there was my vertex. What was my C value? 2.5. Which direction was the graph going? It opened up because A was positive. So I'm going to go up 1, 2.5. So right there, there's my focus right there at -7, up 2.5. And what was my lattice rectum length? 10. So I'm going to go from there to the right, 1, 2, 3, 4, 5, and to the left, 1, 2, 3, and I'm off the graph here, 4, 5. But either way, I've got my 2 points. I can sketch a pretty decent looking graph. And you see how it kind of takes care of, once I have that in there, it kind of describes, oh yeah, it was a little wider because it just happened to have a bigger lattice rectum. Are you seeing that? Okay, so if you look at a graph and you see an A value like these that are all between -1 and 1, and I see that here on all of these, I'm going to use the lattice rectum method of doing this. Now, last thing real quickly. If you have skinnier openings, like 3, -4, or 2, I'm going to use what I call the cheap trick. And it's called the cheap trick, named after the 70s rock band, but it has nothing to do with anything. And it's not a great trick, it's a cheap trick, but this is what I'm going to do. Look how the lattice rectum method doesn't work for me. Here's my vertex, -1, 2. Now, according to this, what would my lattice rectum be? A width of 1/3? What's my C value going to be? 1/4 of that, 1/12? This is how I would have to use it. Okay, I'm going up, go up 1/12. Now, do a width of 1/3, which would be a 1/6 each way. Now sketch your problem. Wasn't very useful, was it? So for values that are bigger than 1 or smaller than -1, here's what I'm going to do. I'm not going to do that at all. I'm just going to go from this point. If I see a 3, I'm going to go up 3 and over 1 each way. And I'm going to sketch my problem. But I am not going to go up 3 over 1, up 3 over 1, up 3 over 1. If I do it more than once, what do I end up creating? An absolute value graph like slope. So right here, what am I going to do from my vertex, which is 2, -5? What am I going to do since that A value is far away from 1? Tell me what? Down 4 over 1 each way. And you're going to sketch it. Call it a day. What do I do from -3, 1 right here? Up 2 over 1 each way. And I'm going to call it a day. And that's what I always do. Plug in more X values. But that's a really quick way to get what you need. All right, y'all good one. See you guys. Hold on.